Today we're talking about dividing polynomials. First of all, I'd like to do a quick review of dividing integers. So let's say we have something like 434 divided by 7. What is the first thing we do when we use long division with integers? Well, we want to check the first digit and see if we can divide by 7. We can't divide 4 by 7, so we move to the second digit, and we look at this as 43 now. How many 7s can we fit into 43? Well, 7 times 6 is 42, so 6. We place that 6 above the 3, because we had to include the second digit here. Then we multiply, right? 7 times 6, which gave us 42, and we subtract. So we get 1, and then we bring down this next digit to get 14. Then we do the same thing. We repeat that process. So how many times does 7 fit into 14? It's 2. We place that 2 above the 4, and then we do the same thing. We multiply, so we get 14, we subtract, and we're left with 0. Let's do one more. So if we have 5 dividing 512, we'll start the same way. So let's look at this first digit. We have 5. 5 divides 5, of course. There's only one of those that can fit in there, so we write 1 above that 5. 1 times 5 is 5. We subtract, we get 0. We bring down the next digit, we have 1. 5 clearly can't divide 1, so we also bring down this next digit, 12. How many times does 5 divide 12? Well, 2 times 5 would give us 10, so we write 2 above the 2. That means we have to stick a 0 in here above this digit because we couldn't divide there. So we multiply the 5 by 2, we get 10, we subtract, and we're left with 2. So what are all the different names for all of these things? Well, these, first of all, are called the remainders. This is a remainder. The answer is what we call a quotient. That is the quotient. And the thing that we're dividing by, so here we divided 434 by 7. Here we divided 512 by 5. What we're dividing by is called the divisor. These are terms that we will continue to use as we move forward. So what does this mean? How can we write this? Are there other ways that we can express this? Well, we divided 434 by 7, and we got 62, which means 434 divided by 7 equals 62. That's one way we can write this. We can also say that 434 is equal to 62 times 7. These are statements we can make from what we found here. We can do the same thing here as well. If we divide 512 by 5, so 512 divided by 5 is 102 plus whatever was left over that wasn't divisible by 5. So we can write 102 plus 2 over 5. Similarly, we can also say, I'm going to write it a little bit above because I'm running out of space here. We also know that 512 is equal to 102 times 5, but we had to add on the extra 2 to make it to 512. So these are all the same statement. These are all saying the same thing over here. Now, what does this process look like for polynomials? It's actually going to follow a very similar process that really depends on place values, right? And making sure we have things kind of lined up in the right way. So, and it is very, very similar to this process. So let's take a look at it. Let's say we were dividing by x minus 2, and the polynomial we were dividing was 5x cubed minus 13x squared plus 10x minus 8. I'm going to write the problem on the left and kind of describe the steps that we're taking on the right. So the first thing we want to do is divide the first term by the first term. Of the divisor. This is very similar to what we did with our integer cases, right? So here, the first term that we're dividing is 5x cubed, and we want to divide that by the first term of our divisor, which is x. We've got 5 times 3 x's. We're dividing by 1x, so that leaves us with 5 times 2 x's, so 5x squared. We need to write this 5x squared above its like term. So because it's squared, we're going to write it above 13x squared. So 5x squared. We want the terms to line up. So all of the x squareds are going to be on top of x squareds, x cubes are going to be on top of x cubes, constant terms are going to be on top of constant terms, etc. So, and right above the like term. So, for example, 5x squared goes above negative 13x squared. Okay, so now what did we do before after we wrote something above? We multiplied by the divisor. So we need to multiply 5x squared by x minus 2. So 5x squared times x is 5x cubed. 5x squared times negative 2 is negative 10x squared. And what did we do after we did this before? We subtracted. I want us to notice that our first terms here, 5x cubed and 5x cubed, are the same. These are the same. That is on purpose. These should always be the same. The first terms that we have here should always be the same. We want them to be the same so that they cancel when we subtract. So 5x cubed minus 5x cubed is 0, so I'm just not going to write anything there. And then negative 13x squared minus negative 10x squared is negative 3x squared. So that was our second step. We multiplied by the divisor and subtract. So now we have one term. We can't divide one term by two terms, so we need a second term here. Let's bring down this next one. So we have plus 10x. So we need to bring down the next term. And in our integer example, of course, after we bring down this term, we go through the same process over again. So we bring down the next term and repeat. So let's continue here. Our first step from before was to divide the first term by the first term. So let's divide this first term, now negative 3x squared, by x. So negative 3x squared divided by x. That leaves me with negative 3x. So negative 3x is going to come, and we want to put it above 10x because that's the like term. We want them to be lined up. So we have minus 3x. Then we multiply this term by the divisor. So we have minus 3x times x, so minus 3x squared. Minus 3x times negative 2 gives us positive 6x. And then we subtract all of that. Subtracting negative 3x squared from negative 3x squared gives us 0, which is just what we wanted. Now we're subtracting 6x from 10x, so we end up with 4x. All right, we need to bring down this negative 8, so we have two terms here, and then we can repeat. So we divide first term by first term. 4x divided by x is just 4. So I have plus 4. That goes above my constant negative 8 because it's a constant term. And we multiply. We have 4 times x, which is 4x. And then 4 times negative 2, which is negative 8. We subtract 4x from 4x, we get 0. And we subtract negative 8 from negative 8, and we get 0 as well. So this is our remainder. If you were asked to find the quotient, your answer is this top part. So we found the quotient of 5x squared minus 3x plus 4, and we found a remainder of 0. In the same way that we rewrote this in terms of kind of multiplication in an equation, let's do that here with this problem. So first of all, we know that 5x cubed minus 13x squared plus 10x minus 8, all divided by x minus 2. When we do this division, we end up with a quotient of 5x squared minus 3x plus 4. Right? So that means that if I multiplied 5x squared minus 3x plus 4 times x minus 2, then I would get this numerator. Let's write that below as well. So we have 5x cubed minus 13x squared plus 10x minus 8. And we know that that's equal to our quotient times our divisor. So this is equal to 5x squared minus 3x plus 4 times x minus 2. Now, how does our remainder play into all of this? Well, it's 0, so we don't necessarily have to write it, but we could say that we had to add 0 here if we wanted. In this case, the way we would write it is by writing 0 over x minus 2. I'm going to just kind of put these in squares that are dotted so we know that they're optional. And then this will make more sense when we actually have a non-zero remainder. So these are optional because the remainder is 0. So I would like for us to look at the columns here. If we look at this first column, all the terms here have x cubed. If we look at this second column, all of the terms here are x squared terms. Our third column is all x terms, and our last column is all constants. That's always how these should look. That's always how it should work out. We should always have like terms all stacked on top of each other. If that doesn't happen, something got messed up somewhere. Okay, let's try another one. Let's say we were asked to divide x to the 4th plus x squared plus 1 over x plus 1. Okay, let's write this out in terms of our long division. So we have x plus 1, and then I need to write out my polynomial underneath. We start with x to the 4th. Now, I would like for us to think back to how we had to use all of those like terms, right? We needed to stack them on top of each other. So in this case, what would happen if we got an x cubed term? Well, if I wrote x squared next, then there would be nowhere for it to go. So we need to include a place for x cubed. And we'll do that by writing 0x cubed. We don't have an x cubed term here, which basically means that there are no x cubed terms or 0x cubed terms. So writing this doesn't change the equation, it just gives us a place for x cubed. So next we have x squared because that one is there. And then we need another 0x term because we're missing an x term. And then we have plus 1. These are what we're going to call placeholder zeros, and they're very, very, very important for this method of dividing polynomials. We need to remember these every time. First things first, we want to divide first term by first term. So we have 4x to the fourth divided by x equals x cubed. X cubed needs to go above 0x cubed. If we didn't have that placeholder, we wouldn't have anywhere for this x cubed to go. So again, very important. It's also a way to check if you forget that you have 0x cubed, but you're looking out to make sure that you're putting like terms above like terms, then this will be very helpful. Because you would say, oh my gosh, don't have anywhere to put x cubed. Must have forgotten a placeholder 0. We want to multiply this by our divisor, so we have x cubed times x, which is x to the fourth, and then x cubed times 1, which is just x cubed. We subtract. Our first term gives us 0, right, by design. We're subtracting x cubed from 0x cubed, so we get negative x cubed. We want to bring down our next term, so we have plus x squared. Negative x cubed divided by x, right? Dividing first term by first term. We end up with negative x squared. That goes right here above x squared, right? We want to line up our like terms. Negative x squared times x plus 1 is negative x cubed minus x squared. We are subtracting here. If we subtract negative x cubed from negative x cubed, we get 0. If we subtract negative x squared from positive x squared, we get 2x squared. Next, we bring down this plus 0x. All right, back to the beginning. So we divide first term by first term. 2x squared divided by x gives us 2x. 2x goes above 0x. We multiply this by our divisor, so we have 2x squared plus 2x. And we subtract. We end up with 0, and then 0x minus 2x. So we have negative 2x here. We bring down the 1, last but not least. We divide negative 2x by x. We end up with negative 2. We multiply negative 2 times x plus 1, and we get negative 2x minus 2. We subtract all of that. We end up with 0, which we don't need to write, and then 1 minus negative 2, or 1 plus 2, so we end up with 3. Now, we've finished our quotient. There's no more terms to bring down or anything, so this is our remainder. And this is our quotient. Now let's look at how this looks when we write it out. If we write this as an equation, we can say, all right, we divided x plus 4 plus x squared plus 1. We divided by x plus 1, and we got x cubed minus x squared plus 2x minus 2, but this is really important, we had a 3 left over that we couldn't easily divide by x plus 1, so we need to write it as 3 divided by x plus 1. Again, this is our remainder, and this is our divisor. Right? All of this we could divide by our divisor and get something nice, except for 3. Since we can't simplify the 3 when dividing by x plus 1, we have to write it as 3 divided by x plus 1. Okay, and one last way we can write this, and this equation is going to look like this equation if we multiplied by x plus 1 for every term. So if I multiply this guy by x plus 1, I have x to the 4th plus x squared plus 1, then our quotient, and our quotient multiplied by our divisor, right? If we multiply these together, I would almost get this, but I would need to add 3 because we have 3 left over. Let me show you exactly what that would look like. So we're saying if I multiplied x cubed minus x squared plus 2x minus 2 by x plus 1, what do we get? So I got x to the 4th plus x squared minus 2. In order to make this look like our numerator from our division problem, we need to just add 3, right? So this is where our remainder comes from. If we add 3 to this, then we get x to the 4th plus x squared plus 1, and that is our numerator. So that's where this plus 3 comes in. I don't have enough room to write a new problem down here, so I'm going to use this space to write a big old, don't forget, placeholder zeros. Before we move on, again, I would like to point out how if we look at these columns, they're totally lined up, right? All of these terms are x cubed, all of these terms are x squared, all of these terms are x, and all of these are constants. That's very important and totally by design. Okay, let's try another one. This one is going to be a long one, but we're going to do it and get through it together. Let's say you were asked to divide, get ready, 3x to the 6th minus 2x to the 5th plus 2x to the 4th plus x squared minus 2x plus 1, all by x squared plus 1. Whew. Okay, so let's write this out as our division problem. So I have x squared plus, can I just write 1? I can't just write 1. We need to remember our placeholder zeros in the divisor as well. That's really important. So we have that 0x in there. And then we write out all this stuff. So we have 3x to the 6th minus 2x to the 5th plus 2x to the 4th plus 0x cubed, right? We're missing an x cubed term, so we need a placeholder, plus x squared minus 2x plus 1. Let's just dive right in. So we divide first term by first term. We've got 3x to the 6th divided by, this time, x squared, because that's the first term of our divisor. The past two problems have been just x as the first term of our divisor, but now we have x squared. If I divide 3x to the 6th by x squared, I've got 3 times x times x times x 6 times, right? Divided by 2 x's. So 2 of these x's underneath are going to cancel with 2 of these x's on top, so I end up with 3x to the 4th. 3x to the 4th needs to go above 2x to the 4th, so we have 3x to the 4th here. I multiply this by all of the terms in the divisor. So I have 3x to the 6th minus or plus 0x to the 5th plus 3x to the 4th. I'm subtracting. So I have 0x to the 6th, negative 2x to the 5th, and then 2x to the 4th minus 3x to the 4th is negative x to the 4th. I need to bring down a third term, so we can divide by a divisor with 3 terms. I divide first term by first term. I have negative 2x to the 5th divided by x squared, which gives me negative 2, and then 2 of these are going to cancel with x squared, so we have 3 x's left over. So we have 2x cubed. 2x cubed is going to go right above 0x cubed. We multiply, so we have negative 2x cubed times this divisor. So we have negative 2x to the 5th plus 0x to the 4th minus 2x cubed. We subtract. We get 0 here, right? These guys cancel. Negative x to the 4th minus 0x is negative x to the 4th. And then 0x cubed minus negative 2x cubed is plus 2x cubed. We bring down this next term. And we start again. So dividing first term by first term, we have negative x to the 4th divided by x squared. So we have negative, there are 4 x's on top, 2 x's underneath. So we end up with 2 x's on top. Negative x squared needs to go above positive x squared. We multiply by our divisor. So we have negative x squared times x squared. So negative x to the 4th. These match, that's good. Plus 0x cubed minus x squared. We subtract all of this. We get 0 here because we're subtracting. We get 2x to the 2x cubed minus 0x cubed is 2x cubed. And then x squared minus a negative x squared is plus x squared. So we have plus 2x squared. And then we bring down this last guy, negative 2x. All right, I want to divide first term by first term. So 2x cubed divided by x squared. Then I have 2 times x. I'm left with 2 times x. 2x needs to go above our other x term, so we have plus 2x up here. We need to multiply by our divisor. We have 2x times x squared, so 2x cubed plus 0x squared plus 2x. I'm subtracting. These guys will cancel. 2x squared minus 0x squared is 2x squared. Negative 2x minus positive 2x is minus 2x. So we have negative 2x minus 2x, or negative 4x. And then we bring down this plus 1. Last but not least, we have 2x squared divided by x squared. This leaves us with just 2, so we have plus 2 on top. 2 times our divisor is 2x squared plus 0x plus 2. I subtract. These guys cancel. Negative 4x minus 0 is negative 4x. And 1 minus 2 is negative 1. I've reached the end of our quotient, right? There's no more terms to bring down, so we are done. This is our quotient up top, and this is our remainder. So it's important to note that remainders can be more than just a constant term. So here, our quotient is all of this. I'm not going to rewrite it because it's a bunch, but our remainder is negative 4x minus 1. In order to make this a little bit easier for ourselves, I'm going to say that this is f of x. We're going to call this function f of x. So if this guy is f of x, that means that I can write f of x as our quotient, so 3x to the 4th minus 2x to the 3rd minus x squared plus 2x plus 2 times our divisor, so x squared plus 1, plus our remainder, which is negative 4x minus 1. Right, again, we have our quotient times the divisor, whatever we divided by. We know that when we multiply these up, we get really, really close to our f of x function, but we are negative 4x minus 1 off, so we need to add that on at the end. Okay, awesome. Let's try some of this in the lab manual really quickly. So this is the section dividing polynomials in the lab manual. Let's say we were given something like this. We definitely have to write it in our long division form. So we write this out. We have x squared plus x plus 2. We're not missing any terms for our divisor. Our numerator here, we have 4x to the 4th plus 3x to the 3rd plus, we are missing an x squared term. We want to be careful. So we have 0x squared plus 2x plus 1. So we have this placeholder. We cannot forget that. So we divide first term by first term. We have 4x to the 4th divided by x squared. That leaves us with 4x squared. 4x squared has to go above this 0x squared. Good thing we had the placeholder there. So 4x squared, we multiply by our divisor. We get 4x to the 4th plus 4x to the 3rd plus 8x squared. And we want to subtract all of that. We get 0 for this first subtraction. 3x cubed minus 4x cubed gives us negative x cubed. And 0x squared minus 8x squared gives us negative 8x squared. We bring down this next term, so we have plus 2x after that. We divide first term by first term again. So negative x cubed divided by x squared gives us negative x. So I have minus x up here. I multiply this term by our divisor. We have negative x cubed. Negative x times positive x is negative x squared, and negative x times 2 is negative 2x. I subtract all this. These cancel. I have negative 8x squared minus a negative x squared, so plus x squared, so negative 7x squared. And then 2x minus negative 2x, or plus 2x, is plus 4x. I bring down my last term here. Negative 7x squared divided by x squared gives me negative 7. So I have negative 7 here. Negative 7 times all this stuff is negative 7x squared minus 7x minus 14. So I subtract it all, and I end up with, these guys will cancel. I have 4x minus negative 7x, so plus 7x, which is 11x. And then 1 minus negative 14, so plus 14, so 15. So my quotient here is 4x squared minus x minus 7. And my remainder is 11x plus 15. All right, that's what we get here. So now that we've talked about how to divide using long division, which is very important, we can only use long division to divide questions like this where we have quadratics in the numerator, we're going to talk about another shorter way to divide simpler equations like this one, where we have x plus 2 underneath, a factor of x plus 2. A lot of the division problems that we'll see for this semester will look like this, where the divisor is something like x minus some constant. But in the case where we do have quadratic equations, like the previous example, we need to know how to use long division to divide polynomials for those problems. So let's talk about this new method, and then we'll come back and solve this question as well. So synthetic division. This is our new method, that's what it's called. We will use synthetic division, or you can use synthetic division when the divisor is x minus c, where c is some constant. So let's say we were looking at the example 5x cubed minus 13x squared plus 10x minus 8. And we were dividing by x minus 2. So in this case, we do have this divisor that allows us to use synthetic division. Our constant here is c, so we have c equals 2. I want to note that underneath we have this term that looks like x minus 2. This looks like a root, right? This looks like a factor of root form. I'm going to point this out early so we can kind of have it in our heads. What we're dividing by, our divisors, are going to look like roots from root form, and the c value that we choose is going to be the root. And the reason it's important to point that out is that when we are talking about a root that's coming from a factor, in the factor it has the opposite sign, right? So here c is 2, but inside of this factor it's minus 2, right? If we had a c value of negative 3, then we would have x plus 3 underneath. Or if we were given a problem with x plus 3 underneath, we would need to note that our c value is negative 3. So again, I'm going to write our steps kind of off to the side here so we know what's going on. 1, write c in the upper left corner, followed by the coefficients of what we're dividing. So I'm going to do this problem over here. So I have my c value of 2 in the upper left corner, followed by the coefficients. So we have 5, negative 13, 10, and negative 8. Step 2, we want to draw an L shape with some space. So that is going to look like this. It's a L with a long tail. All right, step 3, we bring down the leading coefficient. Now I'm going to write some of these steps with these circled, and then so that I can sort of point out where we're doing that here. So bringing down our leading coefficient, this is step 3. The next step that we want to take, we want to multiply by C and right under the next coefficient. So we multiply 5 by 2, right? That's our C value. This is step 4. And right under the next coefficient, so 5 times 2 is 10. I'm writing that under negative 13. Step 5, I need to write the sum of the numbers below the line. So I add these up. I have negative 13 plus 10. I end up with negative 3. This is step 5. And then step 6 is to repeat steps 4 and 5. So repeating steps 4 and 5 here, we multiply this number underneath by 2, so we get negative 6. We add these up, we get 4. Again, I multiply 4 by 2, I get positive 8. And I add these up, I'll get 0 underneath. All right, so what does this mean? We've got a bunch of numbers sort of organized in a crazy way. What's underneath? Is the coefficients of the quotient followed by the remainder. So that means, first of all, our last term here is the remainder. These are the coefficients of our quotient. Last term is the remainder. So remainder is 0. And our quotient is, well, we've got a bunch of numbers. How do we turn them into a function? Well, we've got 5, and then it'll have something, and then negative 3, and then it'll have something, and then we have plus 4, and then something. So we can kind of work backwards here, right? So we know that our last term is going to be our constant term, so it won't have any sort of x's attached to it. Then our next term will be our x term. So we have an x here, so we have negative 3x. And then our first term is going to be x squared. So we're kind of, as we move along, we have higher exponents each time. So we have x to the 0, which we don't have to write. We never write that. And then we have x to the 1, or just x, and then x squared. So our quotient is 5x squared minus 3x plus 4. Now, if we wanted to, we can compare this to what we did at the beginning of class, our first example here, right? We actually did the long division for this problem, and we got 5x squared minus 3x plus 4, right? Now we know how to do it in a way that is a bit faster. Okay, let's try another one really quickly. Let's say you were asked to divide 2x cubed minus 7x plus 5 by x plus 3. We can totally use synthetic division here, right? We have x plus 3, which looks like x minus c, right? X minus c, but what is c? So remember what we said last time. It's kind of like looking at a factor and finding the root. So if we had a factor of x plus 3, it would mean we have a root of negative 3, right? We have to switch the sign. So here, my c value is negative 3. let's go ahead and set this up. So we have -3 in the top left corner, and then kind of our L shape, and then our coefficients. So we have 2. And then notice our next term is -7x. Our first term was x cubed. We're missing an x squared term. So we actually do, in this case, also need to write a 0 term as well. So we have 0, -7, and 5. So placeholders matter here also. Right, so we need to add in placeholder 0. Okay, so we bring down our leading coefficient first of all. That's 2. We have 2 times -3, which gives us -6. We add up, we get -6, right? -6 plus 0 is -6. We multiply by our c value, we get +18. -7 plus +18 is +11. And then 11 times -3 gives us -33. -33 plus 5 is -28. So again, these are our coefficients. And this is my remainder. So what does this mean? This means that I can write 2x cubed minus 7x plus 5 divided by x plus 3 as our coefficients, which tell us our quotient is 2x squared minus 6x plus 11. Right, we kind of need to work backwards, right? We know that 11 is going to be our constant term, so minus 6x will be our x term, and then we have 2x squared, plus our remainder, -28, over our divisor, so x plus 3. All right, let's try that example from the lab manual that we were talking about earlier. So again, we're looking at this one here. We have x plus 2, which means that we have a c value of -2, right? So we can go ahead and write -2 up top. We need our sort of L shape. Our coefficients here are 3, -1, +1, and -2. We bring that leading coefficient down. We multiply, we get -6. -1 minus 6 is -7. -2 times -7 is +14. 14 plus 1 is 15. And 15 times -2 gives us -30. -30 minus 2 is -32. So here we have our coefficients and our remainder. Our remainder here is -32. That's pretty simple. Then we have 3, -7, and 15. How can we write that as a function? So again, let's work backwards. So plus 15 is our constant term, so it doesn't need any x's. We increase from x to the 0 to x to the 1, so we just have x here, so we have -7x, and then 3 is x squared. So our quotient is 3x squared minus 7x plus 15. Simple as that. Okay, I know that was a really long lecture. Hopefully you're feeling pretty good about this. This will be very, very useful as we continue to move forward, working with polynomials in lots of different contexts. So we will use this in the future. Okay, thanks y'all.